Good. Hello and welcome to lecture, I don't know, 32, something like that. There were two, actually, let's start with a topic unrelated. There were one or two things I wanted to do last class that I didn't get to. One very interesting problem. Coming in 1 second. As soon as I find my piece of paper. Are you?
I'm dumb.
Okay, I can't find this, so I'll just wing it. No, I found it.
No, I keep my dumb because like how I get sick of the bus. I give them dumb bus today.
Can you just like yell at them? Can you just like glare at them and like get off on them?
Okay. Hey guys. Sandy, last week we learned about the FTC. Yesterday, Monday, we talked more about the FTC.
Is this notes?
This is notes. We're gonna take notes for a couple minutes. We're gonna go over homework, then more things. So one thing that I didn't talk about, there's this somewhat artificial category of problem, which, however, depending on how you feel about this, is sort of important or maybe silly. I don't know, but it definitely comes up a lot. First of all, just to make sure we're all cool on the FTC, if I try to differentiate, for example, the integral from 5 to x of the square root of 1 plus t squared dt, what is this? Sandy? Wait, actually wait, no. Hold on.
It's just square.
Yeah. But remember, t is like a dummy variable. Did we have this conversation? T is what's called a dummy variable. This is like, since you guys have experience with computer science, you can kind of think of t as like a local variable. It has no meaning outside the integral. The t is just the letter which we use to explain that the function we are integrating is, the 1 plus square root of 1 plus something squared function. It would be just like, remember how like in Algebra 1 or whatever, and you're like, hey, here's a function. The function is x squared plus 5. But like, Sandeep, if instead I chose to write the function as f of y equals y squared plus 5, so same function, different function. Of course it's the same function. Yeah, it's the same function. It's just the take whatever you give me, square and add 5 function, right? So the choice of variables are relevant. This is what we mean when we say dummy variable. The variable x is being used only to explain that the function is the one that it is, right? But the letter you actually use is irrelevant. This comes up with integrals also, right? If I take the integral from 0 to 1 of x squared dx, do you guys have this memorized yet? What do you get?
1/3.
Yeah, this is just 1/3. Actually, you don't need to memorize. You could just do it on the spot. It's definitely 1/3. Well, what's the integral from 0 to 1 of t squared dt? It's also 1/3, right? So because the integral is a number, and so the variable use zero. That's what we mean when we say dummy variable. So yeah, the actual variable that we're differentiating with respect to is x, and so the rate is going to come. So, all right, everyone good? This is just a fundamental thermodynamics. All right. So now, what if I mix it up a little bit? So suppose instead I differentiate the integral from 5 to sine x, root 1 plus t squared. This actually does come up in certain physics contexts in which you define quantities in terms of an integral. In this class, it's only going to come up in these sort of artificial settings in which I ask you weird questions like this. The AP exam is really fond of asking this kind of question because it's sort of a theoretical way of testing if you understand the FTC. Does anyone know what to do? Just like instinct and like take a good, feel it out, or maybe actually know the answer and have a good reason.
Wait, if you're putting it up there, that means sine x is actually just a number.
Yeah.
So you could just say like, It's actually just root 1 plus sine x squared, or sine squared x.
Sounds kind of convincing. So you think you just like basically do with the sine x what you used to do with the x, and just like do that. Calvin's giving you the thumbs up. Yeah.
But when you have to do like chain rule, because like if you're putting it in.
Robbie.
I agree with Yo, but I think you have to, that you're just like having another function which is sine x.
Yeah. Yeah, this is kind of weird, right? Now what we're doing is, this was weird enough, right? That we have some weird function that we're integrating under that function, and now we're asking for the rate of change of that variable. But now the rate at which that upper limit of iteration is changing also depends on sign, right? And so yeah, you have to do the chain rule. Alright, if you get that, and usually what happens each year, there are about 3 or 4 people who just find that to be clear, then like, good job. So Yael, Robbie, good job. If you find this to be a confusing pile of weirdness, then I will help by being a teacher. And one way that you could think about this to make this a little bit more obvious is to temporarily, so this is the issue. I want to know what this is, right? So one thing you could do is you could just temporarily define a new function, g, to be the integral from 5 to sine, no, sorry, the integral from 5 to x of root 1 plus t squared dt. Cool? Okay. And tell me what g prime is. We're like recording all this, right?
Yes.
Yeah. Okay. What is g prime?
The square root of 1 plus x squared.
Yeah, this is just the square root of 1 plus x squared, as we've already discussed. This is just apply the fundamental theorem of calculus. Okay, well, now let's talk about our function. Now let me define a function h. And h is the function that is this guy. So it's the integral from 5 to sine of root 1 plus t squared dt. And you know, h prime is the thing that we don't know that we want to know. Okay, well, by the way, it makes no sense for you to just like sit here because we're going to do this whole lecture like today and tomorrow. So you should like go to a room somewhere and like do all your homework that you owe me. Just like this. Okay, good. Bye. What? Would you have a study hall now or something? You need to go. Okay, good. Bye.
Yeah.
Do you have like a? Who's your teacher? Can you just ask the trainer to look up your grades and he'll tell you what you're missing? Okay, good. All right. So yeah. Why does it help to write it all out like this? Does anyone see where this is going? You can sort of express h as something, right? You can say, well, if this is g and this is h, then in fact h is just. Oh, I thought this was working, but apparently it's not working.
5 to x, and then like x to sine. I don't know.
But sin x is like smaller than that.
H is just the H is just the.
To x.
What's
That's
up?
like 5 to x plus like the thingy x to sine.
Oh, I see what you guys are talking about. No, you're missing the whole point. H is just the function that you get when you plug sine into g. H is just g of sine. Right? Does that help at all? In other words, okay. So the whole reason to be doing this is I'm trying to make it be more obviously a situation in which you have to use the chain rule, right? And so by temporarily defining this function g and temporarily defining this function h, then we can just see h for what it is, which is the composition of the g function and the sine function, right? Because if you just take sine and plug it in here to, am I doing this right? I think I am, right? Yeah. Yeah. Okay, and thus, by what we know about how the chain rule works, what is h prime of x? G prime of sine x, back inside, for the derivative of sine, which is cosine.
Oh, smart.
And that is exactly what sort of like Robbie and Yale just kind of did, like in one step, because what is G prime? If you wanted to now do G prime, that's this, right? So it's the square root of the G prime function is that, so it's 1 plus sine squared x times cosine. Alright, I feel like there's no reason to like dwell on this. Are you guys pretty much cool with this? Okay, cool. Alright, then there was a bunch of homework. The homework was basically like a bunch of integrals. What should we do? Should we put them up on the board? I feel like we should put them up on the board.
Me? I'll do something.
Let's do like, I don't know, like half or something. Let's put like about half of them up on the board. What,
160. Oh my gosh.
a couple of them are hard too.
42.
I just did
What, like, 160?
So what was it? It was like 95, 99, 101.
I didn't know how to do that.
Oh, crap. 103, 107,
And then it also fits like cutting it like every other 11 and then 150.
Yeah. And then like more.
Other problems. One time when we're like one episode like 4 more problems.
137, 139, 142, 160,
Okay, let's do a whole bunch of, should we just do all of them? Let's just do all of them. Alright, grab a marker. Okay. Whoa. 95.
And then for side, it's like 2 times. Like this. So this one, then it'll be like so it'll be 2 times.
Yep. Grab marker.
Should I just like, Mr. Rose, should I just have the camera watching the work?
Yeah, just have a camera and just like, you can like tan if you want. Yo.
Can I get a drink of water?
Yeah.
Yo, like blocking the camera. Yo, don't like, you're ruining Mr. Rose's important film. And people on the internet are gonna see you and they're gonna be like, that kid's a scrub. Scott, don't be a scrub. Like, Damian's already like enough scrub on this camera.
Wait, did you see it?
Yeah. So.
But you didn't stop.
No, he told me not to.
137, 139.
Wait, what's the question?
Rohan, can you throw me a marker? No, the black one. The black one.
Oh, okay, I get it.
And the mixed terrible.
Shirt's really bright. I went to a neon party over the weekend. Yeah. You were supposed to wear neon. But I didn't really have any neon. So right neatly, use the thick part of the marker, don't use marker with that. Why are you all crowding up? Can you do, how about some of the ones back there?
You guys have to.
Yeah, you see, it's because I'm a bad student.
The one after.
Why?
Just you. You're the closest to everyone.
What's up?
No, I'm legit was observing that our table was just like all sitting down rather than helping do problems.
Robbie's mind controlling.
Robbie's not allowed to. Ooh, nice. Strong shirt. Oh, nice.
Oh, wait, what? What does it say?
It's like a pun.
Wait, I want to see it too.
Yeah, Steven, the people on the internet need to see it. If they heard Mr. Everyone's talking right now.
Zoom in a little
Representing the
bit.
street is like
Nah.
like the street. I don't know, maybe it's not that good. It's just Sesame Street. I like it.
111.
Well, they've been classical attention to Steven Street.
I wonder if anyone actually watches this.
Here's the thing is, it's like, there have definitely been times where I like realize there's like a gap in my notes or something.
Alright,
Like,
130. You need a marker? Ron, you doing 137? Hey, Donyan, green. Nope. No, never green. Invisible from more than 1 foot away.
No, I can see it.
No, I can't see it.
No, I can see that there's like green writing.
I can see it now, I can't.
Is I line up 2 to the 7 halves, and I 8 and 2, these 2 to the 7 halves, 2 to 7 is 128. 128.
If it doesn't work, throw it out and request a new marker.
That's like a bad philosophy.
I know, I feel very mercenary right now because I started up really late.
What were you doing?
Start my homework essay.
From what
You
class?
don't understand how. Some of you don't understand how markers work. But whatever, that's alright. It's me. Just do the
I
problem.
like essays. So I work.
Some essays are fun, but like essays are not like
Well, it
fun in
wasn't
general.
fun. I didn't work first work. So I
That's
didn't
true.
work.
That's true.
It was 1984 essay.
That's
You
true.
need to like use the.
That's what?
Yeah, you'll figure
That's
it out.
true, I said.
Experiment with all of the various.
Because it's like,
Yeah, so I did like
Like, I have a
the
6
sort of
pages.
speed yesterday, like your homework. Ethan. What do you
Good. Can we like kind of start?
That's against my principles. I have, it's against my religion.
So 95 integral from -1 to 1 of x root x squared plus 1 cubed. Let's see what this person did. They said that they let u be x squared plus 1, then du is 2x dx. I totally agree. Now they're going to convert to a new integral. So if we stick in a 2, undo the damage of the 1/2, u of -1 is u of -1 is 2 and u of 1 is also 2. So this turns into 1/2 the integral from 2 to 2 of u cubed. Is there another way we could have done this problem? Everything that this person did is correct. Is there something else we could have done?
You could have done the option 1. Oh, you could have like noticed that it was like
Yeah, you
one
could have
and
just
then-
noticed straight off the bat that this is an odd function. It's an odd function because, I don't know, because x squared plus 1 is an even function, and an even function cubed is still going to be even, and the product of an odd function, and an even function is odd. Do you guys see what I'm talking about now? In retrospect, since this is an odd function, the integral from -1 to 1 over an odd function must be 0, because the same kind of stuff. Ron, you cool?
Yeah.
Okay, good. Or you could just do it and it turns out to be 0. 99, integral from 0 to 4 of 1 over root 2x minus 1. This person is also doing it the good way. So they're saying let u be 2x minus 1, so du is 2dx. So we stick in the 2, undo the damage, and we, this is not extremely legible, but I can read it, seeing as I'm like,
The teacher.
yeah, anyway, u of 0 is negative, what? Shouldn't that be -1? What's going on there? Should that be -1?
Oh, yeah, yeah.
Yeah. Is this you, Raymond?
Yeah.
Yeah. So that should, u of 0 should be -1, and u of 4, wait. You have the wrong problem listed? Is that the issue? Like, you just wrote the problem down wrong. Like, but you probably did it right on your paper. Is that what's happening? Raymond?
No, I wrote it down wrong.
How'd you?
Oh, yeah, I did it wrong, yeah.
Okay, so, but I think, is this the right answer?
Yes.
Yeah, because if the function, it's kind of weird. Alright, so if the u, I'm not sure what to say about that. If the u sub is 2x plus 1, then du is 2x is 2 dx, so we put in the 2, undo the damage of the 1/2, replace 4 with u of 4, which is 9, replace 0 with u of 0, which is 1. And then, yeah, good. Okay, how about 103? More of the same. Here, if we let u be 3 over x, then du is, does that say negative? -3x to the -2, which is exactly what we have here. So we put in a -3 and undo the damage with a -1/3, and then we convert the integral to be in terms of u. When we convert the integral, we convert the limits. And when you plug 1 into here, you get 3, and when you plug 3 into this function, you get 1. And then this person did exactly what I would do in this situation, which is, because this is an integral from 3 to 1, they flipped it back. So it becomes, again, the integral from 1 to 3. Is everyone following this? So it's 1/3 integral from 1 to 3, and then at that point you just do the integral. The antiderivative of e to the u is just e to the u, and so you get boom. Beautiful, wonderful. 107 was a little bit harder. I think these problems are, I don't know, I think they're kind of hard. If we let u be 2 minus x, then du is negative dx, and then you can solve for x, x is 2 minus u. So then you go back in and you say, okay, well in that case, if x is 2 minus u, then in place of x minus 1, I can write 2 minus u minus 1. Put a negative in there, and then that root 2 minus x becomes root u. Everyone see what this person did? And so then it turns into, upon doing the algebra and simplifying and distributing the negative, that ends up being like 1 minus u, so it's like u minus 1. Is that what this person did? Yeah. -1. Wait, I'm kind of confused actually. Something wrong? I feel like it was right up till here. Did you guys get 4/15?
Yeah.
No, I got 4.
I'm not following actually what happened here. This is 1 minus u. Oh, okay. But then what happens to the negative? Oh, I see. This person's doing like a whole bunch of things all at once. Because u of -1 is in fact 3, right? That's what I don't understand. Isn't u of -1 3? Oh, that's why. God. Okay, so, yeah, so u of 1 is 1, and u of 2 is 0. Okay, so this, Cindy, is this you? So you sort of like evaluated those and also flipped the negative and also simplified and also distributed and also split it up all in one step?
Yeah, no, I got space in the board. I have time.
Okay, well, okay, if you write so many steps at once and no one can even follow what's going on, then it's not much of a use of putting it on the board, is it? Okay. Can we like refocus? Is this helping going over these?
Yes.
Okay. Alright. Answer 415. It's a lot of, actually there's like a lot of separate things you need to do this problem correctly. Let's just move on. Integral from -1 to 2 of 2 to the x. Here you need to be able to anti-differentiate 2 to the x, which this person does, so this one's pretty straightforward. Boom. This problem 115 says, what is this person doing?
It was basically like that's the derivative of the function, and it goes through the point 5,4. So what's the
Right.
function?
Yeah.
Yeah.
So did you do it?
Yeah.
Where?
I was like, just random.
Oh, I see. Okay, so
I
this.
think I skipped the step like the very first time.
Oh my god. Okay, so yeah, so if dy dx is 2x over root 2x squared plus 1, then y is going to be some kind of antiderivative of 2x over root 2x squared plus 1. And then what Yael does is to solve this anti-differentiation problem by letting u be 2x squared plus 1. And then she does it the other way, where you're like, right? What are you doing? You like, okay, I see. So then du dx is 4x. So then dx, you solve for, you always do it this way? You solve for dx, and she writes it as du over 4x. So if you stick that back in, things cancel, and you eventually end up here, which, when you then anti-differentiate that, you get that. And then she substitutes the thing back in. So the conclusion is that this function y has to be like this plus c. It's going to be one of those functions. And to figure out what c is, you plug in the point 5, and that gives you, what does that give you? What's up? Yeah, but, sorry, I'm confused. If you plug in the 5, don't you get root 51?
No, root 49. Minus 1.
How come more than 50% of you have written the wrong problem? This is -1?
Yeah.
The whole time?
Yeah.
Okay.
Oh, yeah.
God.
Oh, yeah. I have
Okay.
none on my paper.
Good.
I looked at that.
Plugging in 5 yields 7, and so, but if it's supposed to yield 4, then C must be -3. Follow? This is like the worst go-to homework ever. All right, let's go a little faster. 117. Any questions? This problem is actually kind of hard. Did you guys figure it out? That's the answer. 1209 over 28. Let's see what brilliant work.
I have
What's
a
up?
question
Yo.
just in general. So you switched the range of the integral because you don't want to have to go back to x's, right?
Pretty much, yeah.
Okay.
Yeah, I mean that's exactly, yeah, so just to like recap, because this handwriting was actually pretty decent. We're taking the integral from 0 to 7 of x plus 1 to the 1/3, and then I guess there's like a dx in there also. So she says, let's let u be x plus 1, and then du is just dx, and if you do that, it suddenly converts to u to the 1/3 u minus 1. But at the moment that I convert the integral from an x integral to a u integral, then I need to change my limits. And so 7 becomes, via this formula, 8, and 0 becomes, via this formula, 1. So then this is really just the integral from 1 to 8 of u to the 4/3 minus u to the 1/3 du. And she just does it, and then, I mean, I guess you didn't show your work and stuff, you just kind of like went to the answer. Did you have a calculator or something, or? I joked. Okay, good. Let's like try to finish this. 125. Nice. 125 says something like find the area in between something, something, something. Is that right?
Nice. Maria's on.
125 says find the area between 0, root 6, and the y-axis, and the function is xe to the negative x squared over 4. Okay, so yeah, so basically you just do it. Do we need to talk about this? I'm getting bored of going over this homework.
Can you go over 168?
Let's just skip to the ones which are hard. Which ones were hard?
168.
159.
159 and 168 maybe? 159 was a good problem. 159 said show that the integral from 0 to 1 of x squared 1 minus x to the 5th is the same as the integral from 0 to 1 of x to the 5th 1 minus x squared. And basically, let's see, who did this problem?
Park.
Who did this problem?
Great.
House Park says, okay, let's just start with the left and like see what happens. So she begins with the left-hand side, and then says, okay, well, in order to make this look like this, I'm going to do a u sub with the 1 minus x. So if I let u be 1 minus x, then du is negative dx. So she puts in a negative, undoes the damage with a negative. And now let's convert everything to u's. So just like we did in class yesterday, this becomes u of 1, u of 0, and u of 1. And x is now 1 minus u squared, and this is just u to the 5th. But then u of 1 is 0, and u of 0 is 1. So this is actually perfectly clear, I think. And then, because there's a negative there, I can just flip these, so I do, and just rewrite that slightly, and then basically I get all the way down to this, and this just is this, because the variable is irrelevant. So actually it's just a direct translation of one integral into another. Cool? Mateo, you cool? Okay, the last problem says, which apparently scared you guys off. It said verify, and can someone erase that board also while I start? It said verify verify that the antiderivative of u sine u du is sine u minus u cosine u plus c. Okay, in other words, they're basically just telling you that this is the antiderivative, but they want you to check to make sure that it really is. And you'll be able to do problems like this next year after they teach you the technique, or you could just learn it. It takes 5 seconds. So they're not actually asking me to anti-differentiate this, they're just giving me the answer and they're saying, hey, check to make sure that works. How do I check to make sure that this really is the antiderivative of this? Just differentiate both sides. So if I differentiate this side, I'm supposed to get u sine u. Okay, so let's do it. Let's take the derivative with respect to u of sine u minus u cosine u and just like see what happens. Well, derivative of sine is cosine, and minus the derivative of u cosine u, derivative of the first times the second, plus the first, and the derivative of cosine is negative sine. And if I distribute this out, I just get cosine u minus cosine u plus u sine u. And thus, it just worked, right? I mean, the derivative of this is u sine u, thus formula verified. Okay, now that you know what the antiderivative of u sine u is, do this following integral. The integral from 0 to pi squared of sine root x dx. Okay, how can we do this? Well, I'm not sure. Let's let u be root x. Well, if I let u be root x, then du is 1 over 2 root x dx. Agree? Yeah. And so now I can do one of those like kind of swingy things, right, where I say dx is 2 root x du. And if dx is 2 root x du, then yeah, now I'm going to convert this into u's. So this becomes the integral from u of 0 to u of pi squared of, well, sine of root x becomes sine of u, and dx becomes 2 root x du. And then, of course, my whole goal is I'm trying to transfer it into integral into just u, so this is really just 2u. So what I end up with is 2 integral u of 0 is 0, and u of pi squared is just pi. So it's twice the integral from 0 to pi of u sine u du. And previously, I would not have known how to do this because I don't know how to antidifferentiate u sine u, but they just told me in part A, or they guided me via part A into now knowing this formula. Thus, this is just going to be twice. Antiderivative of u sine u is just that, right? Sine u minus u cosine u, and I need to evaluate it at pi and 0. Following this? Really
I see, okay.
It's really just a two-step problem. Hey, now that you know this antiderivative, can you do this via substitution? So anyway, final answer, 2, if I plug in pi, sine of pi is 0, minus pi times cosine of pi is negative 1. A lot of parentheses here. Minus what happens when you plug in 0, which is just going to be 0 minus 0. So the final answer is just 2 pi, is that right? Okay. How do you guys feel about this? Integration with substitution? Decent? Scott? Okay, good. Can I have this?